Hello students, welcome to the class once again. So after learning the concept of momentum and we've solved so many problems based on conservation of momentum, and I also told you about impulse. So we practiced many problems, so you must be very much handy about usage of the term momentum and how to use the concept of conservation of momentum in various cases. Today's class will further proceed with the next topic, which actually uses the concept of momentum. So in today's class we are going to learn about collision. This is the topic. We are going to learn about collisions in today's class. Now collisions, you must be very much aware of the term collision. Collision means when two objects collide with each other. A normal physical collision, let's say if you have thrown a stone towards a wall, the stone is going to strike the wall, that means a collision has occurred. Very simple example once again. Let me say you are riding a bicycle and suddenly you see a big brick kind of stone, a big stone you see, and suddenly your bicycle strikes the stone. That means a collision has occurred. These are quite simple collisions. I'm not going to the most different kind of collision, like say suppose you're driving in a car and suddenly your car strikes another car. That's a different kind of collision, and that is also a kind of collision, example of collision. Let's proceed further. Let's go to a formal way of two objects colliding with each other. And let's say how to describe the collision. Let's say I have two objects. This is object number 1, which has, let's say, mass m1, and I have another object which is kept on the same platform and its mass is m2. Okay, now suppose this object is at rest. Let's say let's not move this object. Let us say it is initially at rest, and this object you have given it a speed, some speed, and it is moving with that uniform speed. Let's say you have given it some speed u. As this object moves further ahead, it finds that this object is here, so it's going to collide with this object. So we will say that collision has occurred as it hits the other object. Now as it hits, what will happen? For a very short duration of time, for a very momentarily small amount of time, these two objects will remain in contact with each other, and then they will exert forces on each other. And for that, after the small interval of time, they will again get separated and they will move with some different speed along this forward direction. So this is a very simple kind of collision when this object was stressed. Now let me change the scenario. Let me change the scenario and let me make here a different picture depicting a kind of collision between two objects. Let us say this time we have got two different objects on the same platform. This time we have an object of mass m1, and let's say I have a different object of mass m2, and let's say a spring is attached here. Now if I project this object with a speed, let's say u1, and if I let this object also move with a speed u2, now what will happen? This object goes, it finds that suppose u1 is greater than u2, because if u1 will not be greater than u2, collision will never occur. So it's a waste of time learning this topic. So let's u1 is greater than u2, so that this object reaches this end of spring, and as it touches the spring, and you all know what is going to happen, the spring will get compressed. The spring gets compressed, it means the potential energy of spring will increase, and further after that the spring further reaches to its natural position, and then both the object will move separately with some different speed. So what is happening? We are seeing that object goes, strikes, compresses the spring. Some of the kinetic energy is converted into potential energy. This potential energy will be in the spring till the time it is compressed. That it means that some of the energy which was initially in the form of kinetic energy of these two blocks is converted into the potential energy of the spring. So we get energy conversion that is taking place. Kinetic energy is getting energy conversion that is taking place. Kinetic energy is getting converted into potential energy. Now as the spring will exert a force on this block, and this block, the spring will try to reach its natural length, so it will again convert its potential energy and it will give its potential energy to the kinetic energy of these two blocks. So the next conversion that we are finding that will happen, again spring will attain its initial position, or let's say its initial natural length, and again the potential energy that was stored in the spring will be converted into kinetic energy. And let me tell you, since no external force, let's say no external force is acting on the system, and all the initial kinetic energy is with this system, that is initial kinetic energy will be equal to final kinetic energy of the system when they again start moving with some different speeds. Hope you are getting the idea of the collision that is happening. We are actually conserving the energy here. So what I'm writing, initially they were moving with some kinetic energy, and after the collision they are again attaining the same kinetic energy. Now this was for a general kind of collision. Don't worry about, we will have a situation when the final kinetic energy will not be equal to initial kinetic energy. We will see more kinds of collision, but let me explain you about what we have learned till now. Two objects, again, two objects. We have two objects moving with different speed and they are going to collide with each other. So let's study the basic collision case. Two objects we are having, let's say this is moving with the speed u1, its mass is given as m1, and let's say we are having another object whose mass is m2, it's moving with the speed u2. And suppose they are moving along one straight line such that u1 is greater than u2, it's quite definite that they are going to collide. They are moving along the same straight line and u1 is greater than u2. Now what will happen when they are going to collide? What is going to happen as they collide? We all can think of a situation when they are going to collide during that duration of time, during that time when they are touching each other. Think like that. Two footballs, imagine they are going to collide. So as these footballs come together, the surface on both the footballs will get deformed slightly, although it's not observable by our naked eye. But you think of that, it's a quite deflated football. As it strikes, the surface gets deformed. So what we'll be having in this way. Somewhat in this way, the deformation takes place, and both the objects, during the interval, they are in contact with each other, they will get deformed. So this is what is happening. Now, during the instant they are in touch with each other, still they are moving. So during the instant they are touch with each other, they are moving and they are moving together. That means we will have one velocity of these both objects and they will move with one unique velocity. We got this. Now every object tries to acquire its original shape and size. And this is the property called resilience. This is a property of an object. It's called resilience. It tries to attain its normal shape and size. You know, if you try to deform anything, take a sponge, if you try to deform, again if you leave the deforming forces, it tries to regain its original shape and size. You take a canvas ball, try to deform it by holding and by exerting a force. After the time you have stopped applying the force, you will find that the deformation will cease to be there in the body, and this is property known as resilience. I'm writing, due to resilience, the body will actually regain its original shape and size, or let's say original structure. Now that means, now see, I told you here at this instant it is going with one unique velocity. Initially both the objects have some kinetic energy, and during the time when they were in contact with each other, that means kinetic energy is lost, and that kinetic energy is converted in potential energy of these two deformed objects. So first we find that as you go from here to here, from this situation, we are having kinetic energy is getting converted into potential energy. What does this signify? This signifies that some kinetic energy is lost, and this loss in kinetic energy will appear in the form of potential energy of the system. So what I'm writing, this loss in kinetic energy will be equal to potential energy of the system during the deformed state. So we have this. Next, what happens? It tries to regain its original shape and size, that's original structure. So all the potential energy which was stored in these two objects will appear in the form of final kinetic energy. So what will happen in the next case, as the deformation ceases, then we'll be having, as the deformation ceases, we'll be having all the kinetic potential energy which was there. This will appear in gain in kinetic energy of the system, or let's say they will start moving with different speed. Let's say the different speeds are v1 and v2 of each of the objects of masses m1 and m2. This generally happens in collision. Finally, both the objects are going to have some kinetic energy, and initially also they are having some kinetic energy. Now let us discuss what situations can happen in this general collision case. What situations can happen? First of all, let me give you a very straight way, one big and bold statement: momentum will remain conserved, because that has got nothing to do with the kind of collision. I told you, whenever no external force is acting on the system, momentum remains conserved. So it doesn't matter what kind of collision it is, what kind of energy exchange takes place, momentum will remain conserved at every instant of time, since no force is acting along the horizontal direction. So first point, in every kind of collision, momentum remains conserved, which I am going to write the very first point here. Momentum remains conserved. The very first point. Momentum remains conserved. It doesn't matter what kind of collision is taking place, how the energy is exchanged, that is kinetic energy to potential energy or potential energy to kinetic energy. It doesn't matter. Whatever may be the case, whether you observe the object here, whether you observe the object at this state, or you observe the object at this state, it doesn't matter. Momentum at every instant of time, at every state, it will remain conserved. Now let's come to the next point. What things can happen? I'm going to start with the very first thing. Let us say it is having some kinetic energy. During this instant when they were both moving together, some kinetic energy is converted into potential energy. This we can observe, this we can see straightway. Some kinetic energy is converted into potential energy. Now this means some kinetic energy is lost, as I told you. Now as it is going to regain its original shape and size, if all the potential energy which was stored during the time they were deformed, if all the potential energy is again gained in the form of kinetic energy completely, such kind of collision is known as elastic collision. And since we are doing along one straight line, so we'll say that this is elastic collision in one dimension. Second, what thing can happen? Try to understand it. Second, this can happen that this body, they collide here, and now by the virtue, by the property, let's say they stick together. They stick together and they start moving together. What I'm saying, see here, they're moving with some speed, they collide and they're going to stick with each other. Now they remain permanently stick to each other. They're saying we love each other, we are not going to get separated. So they're going to remain together. That means they're going to move together for all the entire time duration. So such kind of collision, you know what will happen? In that case, the maximum potential energy will appear in the body, or maximum deformation will take place, because once deformed, the body is not trying to regain its original shape and size. It will remain stick. That means maximum deformation case will be there. That means maximum potential energy of the system will appear here and it will remain always. That means the case is of maximum decrease in kinetic energy. Such kind of collision is known as perfectly inelastic collision in one dimension. I will repeat the case. What's happening? They are having some kinetic energy initially. Some part of kinetic energy is converted into potential energy. Now they remain together, they move together with this potential energy stored in them. That means some kinetic energy is lost. That will appear in the form of potential energy. They will move together. That means we will be having the maximum loss in kinetic energy in this case. This case is of a perfectly inelastic collision. Let's proceed further. What third thing can happen? Third thing can happen, let them move with some speed, let them collide, let them the maximum deformation take place. Now, as the object starts regaining its original shape and size, there can be a case when some deformation can still remain in both the objects. When some deformation still remains in the object, that means some potential energy will be stored in the object. And if some potential energy is stored in the object, that means some kinetic energy is lost. Although we are not talking about the maximum case, some kinetic energy is lost and some potential energy will still remain in both the objects. They will get separated and move separately. Such kind of collision is known as partially elastic collision. Three collision. First case, kinetic energy remains conserved. Second case, maximum kinetic energy is lost. Third case, a few amount of kinetic energy is lost and bodies move separately with some deformation, that means with some potential energy with them. That is the partially elastic collision. Three collision: perfectly elastic, perfectly inelastic and partially elastic. So we'll study all these three kinds of collisions separately, and we'll start with the very first kind of collision, that is perfectly elastic collision. Let us start understanding and making equations for perfectly elastic collision in one dimension. The first kind of collision we are going to see, this is perfect elastic collision in one dimension. Perfect elastic collision in one dimension. When I write in one dimension, it's very simple for us to understand. What do we mean by one dimension? That means one straight line in one dimension. Perfectly elastic collision in one dimension. Two objects, both moving with some speed, let them collide. So I am marking here two objects, and let us say these are the two objects. Mass m1, let us say it is moving with initial speed u1. Then we have mass m2, object 2, it's moving with speed u2. Both are moving along the same straight line. The K condition should be very much uniform in all the cases. Both are moving along the same straight line such that u1 is greater than u2. Now, one thing is for sure, they are going to collide. As they are going to collide, they are going to stick, they are going to separate and move with different velocities. So after collision, when they collide, the situation will be something like this, which I am drawing here. For a very short interval of time, they will move with a fixed constant velocity. After the collision, what will happen? They will start moving with different speeds. Let's say this is v1 and let's say this is v2. Three instances I have drawn. This is during collision, and here we have after collision. And this was the case that was just initial case, that was before collision. This was the case when they were moving separately. After collision, they have the speed v1 and v2. As I told you, momentum remains conserved. So that means we can write the very first equation as F external is equal to 0. We can write momentum remains conserved. Just now we have learned the concept of momentum, so it's very easy for you all to recall the momentum conservation. We can write initial momentum is equal to final momentum. Initial momentum is equal to final momentum. That's what we have conserved the momentum. Let us say this is equation number 1. Equation number 1. Now here, if I take m1, if I take this path here, I'll get m1 u1 minus v1. I'll get m1 u1 minus v1 is equal to m2. Here I will get v2 minus u2. Let's say this is equation number 2. Equation number 1, equation number 2, we framed in this way. m1 u1 minus v1, plus here equals to m2 v2 minus u2 we take here. Now during the collision they were moving with a fixed speed. We are not concerned about this case. This was just drawn when they are striking towards with each other. After the collision they are going to regain their initial kinetic energy. That means all the kinetic energy which was converted into potential energy, it is again gained here. So there will be same potential energy which appears here, that will be gained here. So we will be having kinetic energy remains conserved. So I am writing here kinetic energy remains conserved. We are talking about perfectly elastic collision. So if I conserve the kinetic energy, so initial kinetic energy will be equal to final kinetic energy. Not a big problem to write this. Initial kinetic energy is equal to final kinetic energy. We'll get this. Can we equate the energies at the both sides? We'll be having the first relation as half hope that that's very easily you can make out all the variable terms that I'm writing here. It's not tough to make senses how we are denoting the variables. Initial speed, final speed. 2 half of half can be cancelled out. We'll be having a relation m1 u1 square. Take this term here, we'll be having this equal to minus v1 square is equal to m2 v2 whole square. Take this term here, we'll be having minus u2 whole square. Let's call this as equation number 3. Very simple and easy to reach on this equation. This equation, see here, a square minus b square. This can be written as a minus b, a plus b. A square minus b square, a minus b into a plus b. If I divide this equation, equation number 3, by equation number 2, very easily we will get a relation. See what I'm going to get.